Welcome back. Today we're going to look at this on how many solutions can an equation have. And you've got this piece of paper in front of you and we're going to complete this together. So we're going to look at this first equation we have on the left and we're going to draw our line at the equal sign. And from our flow chart that we've talked about previously, we're going to get rid of our distributive stuff first. We're going to clear our parentheses. So negative 3p minus 24 is what I'll have here. And then over here, there's nothing to distribute, so I just bring this stuff down. So I have negative 3p plus 8. And then, after that, I've asked you guys at the pink step to combine your like terms across the equal sign first. So here we're going to add 3p to both sides. And once I do that, what I'm left with is negative 24 equals, because this zeroes out, this makes 0 as well, and I'm left with 24 is equal to positive 8. What just happened? I have negative 24 equals 8. When will that ever be true? Never. That will never ever be true. That's a false statement. 24 is not equal to 8. Okay? So what happened here was we eliminated the variable. Okay, we got rid of it. And we didn't mess up. We eliminated the variable. And when we did that, we got a false statement. Something that wasn't true. 24 is not going to be equal to 8. Okay? Now when that happens, when you've eliminated a variable and you have a statement that's false, the number of solutions that this equation is going to have is no solution. You can look for your entire life for a solution to this equation and you won't find one because it doesn't exist. Alright, next. This next one should be more familiar to you because this is what we've been doing. So we're still going to draw the line at the equal sign. We're going to distribute. So that's the orange step. And we've got something to distribute on the left side only. So we've got 2 times negative 3x is negative 6x. And then 2 times 4 is 8. Equals 5x plus 2. Okay, now we can go to the pink step where we can put things together across the equal sign line. So what I would choose to do is I would add the 6x to both sides. And then when I add 6x to both sides, I'm going to be left with 8 here because those make 0 together. 5x plus 6x is 11x plus 2. Now it's a two-step equation. I eliminate my constant 2 by subtracting 2 from both sides. Simplify. 6 equals 11x. Last step, divide by your coefficient with the same sign. So I divide by 11 on both sides. And I'm going to leave it as the fraction 6 over 11 is equal to 11x divided by 11 is 1x. So there we go. There's my solution. Now if you wanted to change that into a decimal, you would do 6 divided by 11 in your calculator, and there you'd get it. Alright, so what happened here? Nothing real fancy, right? I mean, we were able to keep our variable on one side and a solution on the other side. Okay, so we have a variable is equal to some sort of number. And that number can also be 0. So if we had x equals 0, that would be this kind of equation, which we have been practicing for the past couple of weeks, and that is an equation that has only one solution. And then we have this last section to deal with. So again, we're starting with distributing just on the left side, and I'm going to be distributing a negative to the 7 and a negative 1 to negative 8x. So it's changing the sign of everything in the parentheses. Negative 1 times 7 is negative 7. Negative 1 times negative 8x is positive 8x. Nothing to distribute on the right side, so I just bring this stuff on down. Now we can skip to the pink step of getting our like terms together across the equal sign. So inverse of add 8x is subtract 8x on both sides. Notice that I put the x's right under each other instead of like under the 7. So I'm going to bring my negative 7 straight down. That makes 0 together. That's a 0 pair. Bring this negative 7 straight down. Those make a 0 pair. Now look at this. I have the variables are gone. And then I have negative 7 is equal to negative 7. Well, that right there is a true statement. That will always be true. Negative 7 will always be equal to negative 7. So down here, some characteristics. We've eliminated a variable. We've eliminated all of the variables, but this time instead of a false statement, we ended up with a true statement. Something that will always be true. And this equation has a great deal of solutions. And we call this infinite solutions. Infinite meaning we could search for our whole life and we still wouldn't be able to find all the answers that would work for that equation. Some synonyms that you may encounter would be infinitely many solutions, so infinitely many solutions. And sometimes you will see all real numbers. Okay, those mean the same thing. Basically, this is saying any kind of number that you stick in there would be a solution. So it could be a positive number, a negative number, a decimal, a fraction, or a combination of any of those things. Okay, all real numbers would be a solution. Now, I'm going to go back to a different page that we talked about yesterday. Alright, now, I've had you guys at this pink place. Right here, we've got this little flap that we've glued over top, because when we get to the point where we've got to figure out how many solutions an equation could have, not just what is the solution for every one-step equation. Okay, so we overlapped it to where this box and this box are in the same place. Okay, so some of you glued it to where it flips up, some of you glued it to where it flips to the side, and that's fine. So we've got flow chart here to help us decide how many solutions an equation have. So this pause button right here, when we get to the pink step, this is where we're going to hit the pause button, and we're going to do a couple of things here. So we're going to compare our coefficients. Now remember, your coefficients are going to be the numbers, the number left of the variable, to the left of the variable, okay, and it is the multiplier. It's multiplying the variable. Okay. I can compare my coefficients. Now, if my coefficients are different, that will be a one solution equation. And that means keep going. You can find the solution to this one. But what if my coefficients are the same? What if the numbers sitting left of the variables on both sides are the same? Well, the next thing I'm going to do is compare my constants. And the constants, in case you've forgotten, the constant is the plain old number that's added. Plain old number. Okay? It's not sitting to the left of the variable, it's adding or subtracting to the variable. Okay? That's a constant. Alright, now, if your constants are the same, okay, you're going to have the infinite solutions here. That means everything's the same. Your coefficient is the same and your constant is the same. Everything matches up, you're going to have infinite solutions is the match. Everything is the same. But what if they're not the same? What if you've compared your coefficients, you found that the coefficients are the same, but then when you compare your constants, the plain old numbers, are different? Well, that, my friends, means we have a no solution equation here. That means your coefficients are the same, but your constants are different. So going back to this page, I'm going to erase some of my work here so that we can see what we're doing, because what we can do is actually stop right there, at the pink step, and compare them before we start moving things across the equal sign, and we can know how many solutions it's going to have, which is pretty cool. Okay, so look right here. Let's look at this no solution right here. So I've distributed. You got to distribute, and then if there's some like terms on the left side you need to get together, then you got to do that. Okay, so once you get to that point, the first thing we're going to do is compare our coefficients. Now over here, my coefficients is -3, multiplying p. On the right side, I have a -3 multiplying the p. So I have the same coefficient on both sides, on the left side and the right side. Same coefficient. But then, when I compare my constant, on the left side, I've got -24 and +8. I have different coefficients there. So this, or excuse me, did I say coefficient? I meant constant. Compare your constants on both sides. So negative 24 is the constant on the left, 8 is the constant on the right. Those are different. So if you have the same coefficient but different constants, then you're going to have a no solution equation. Okay, so we don't have to carry it on out to variables are eliminated. You can, but if you can catch it at the pink step, that saves you some time and some effort. Looking at the next one, the one in the middle with one solution, compare your coefficients. So we have negative 6 over here, and we have a positive 5 over here. We're done. Once we establish that we have different coefficients, we know we're going to have at least a solution to this equation, at least one. We don't have to compare the constant after that. Okay, that one's pretty easy to identify. So at least know that there's one solution there. Sometimes that's all it'll ask. Sometimes it'll ask you to find the solution, so then you would have to keep going. Next, let's look at infinite. Now the coefficient here is 8. Here's the pen I need. Coefficient here is 8. And then on the right side, the coefficient here is also positive 8. So make sure you're looking at the sign to the left of those numbers. So I have the same coefficient again. Okay, same coefficient. So let's look at our constant. Our constant on the left side is negative 7. Our constant on the right side is negative 7. I also have, in addition to having the same coefficient, I also have the same constant. If I have everything is the same, everything is the same, everything matches up, then you have, for that equation, an infinite number of solutions. And that's all I have for today. Thanks for watching.